Oh, good afternoon, classes. I'm Timothy Precella, and I want to point out something to you. I just passed out a set of steps that we're going to be using in this upcoming homework assignment.
A paper set.
A paper
copy.
Yeah, which is very rare. I generally don't shuffle papers, but still, I thought this was important enough that you should have a paper copy of it. And I want to show you, here we are at Canvas. If you click on our course, I'm going to put it into student view so this looks more like your account. If you go to Files, and there's the files for the course, you click there, and there it is, the cut point method. So I have a digital copy here on Files, under Files on Canvas for you. By the way, here's the started with getting started with Pearson MyLab. There's the course syllabus. So if you lose the set of steps, then that's okay. It's there under Files on Canvas. There. And we're going to get started right now. We're going to be looking at solving nonlinear inequalities using cut points. To solve nonlinear inequalities using cut points, it's a very logical process.
But let's first tell them what the heck an inequality is. Don't you think so, Tim?
Oh, okay.
Well, at least review them. You've heard the word before.
It's not linear inequality.
I know.
Sure.
But an inequality contains either a less than symbol, a greater than symbol, it might contain a less than or equal, or a greater than or equal. Theoretically, it could contain, if you had a statement with a not equal, you could call that an inequality, but that's not what we're going to be solving today. We're going to solve the things that have less thans and greater thans. It's always important to be able to distinguish how does this problem differ from what we've been doing. Well, when do you do this cut point method that we have? Whenever you see a less than or greater than. The instructions won't say solve using cut points. It'll just say solve the inequality, write your answer in interval notation. You might remember we were reviewing interval notation at the end of class the last time. It's the stuff where you have the shaded regions on the number line with open and closed circles. The closed circles mean you include the number. The open circles mean you're not including. So include, not include, 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 include. And you never include infinity symbols. Use those brackets for closed circles or closed dots, parentheses for the open dots or at infinity symbols. And if you look at that little recipe, I call it a recipe because it's just step 1, step 2, step 3, step 4, step 5. You follow all of those steps and voila, you'll have the answer. Okay? Step 5. You're going to be going through this little process where you find the numbers on the number lines, and that's what we'll call cut points. Then you're going to be shading regions on the number line. And then you wind up with interval or with shaded regions. Look at step 5. Express the, we could zoom in a little on that. Express the shaded intervals using interval notation. Use square brackets for closed circles. Use parentheses for open circles. Always use parentheses for infinity or negative infinity. Okay? So it's a very logical process, and we'll try to justify why this works as we're going through it. Okay?
But I will mention something, though. To me, it's crystal clear while we're doing each one of these steps, okay? But Even if it's not, we're going to try to convey to you why we're doing each step. But if we don't, you can still follow the recipe and get the solutions to these inequalities, even if you don't understand exactly why we're doing each step. I imagine all of y'all drove cars here today, and I bet you there's not that many of you that have that solid understanding of why that internal combustion works the way it does, but you still use your car. Likewise, you can still use the cut point method even if you don't follow why you're doing each step.
Because it works really nice. Like the quadratic formula, we didn't justify why on it. But it works. And a word of warning, we give a name to this procedure. We call it cut point method. If you're going to read through a book, or if you look at view an example, they never say cut point. It's just sort of some steps, and there's not a name. I love to give things names. When I say cut point, by the time you're through with this, you're going to know, okay, that's something that deals with a less than or greater than. We're going to draw the number line and shade regions. Okay? So
realize the cut point method can be used for linear inequalities where there's just 3x plus 2 is less than 5, something like that. But what we're focusing on, I know that linear inequalities are done in the, what is it, Math 371?
It used to be section 2.
I would remind you of that, but why bother? The cut point method solves linear inequalities also.
The cut point method will solve any type of inequality. I remember years ago when a teacher told me, actually it was a tutor, said, I thought, that cut point method of yours is amazing. It'll solve any type of inequality. And they could have just stopped right there, but instead the person went on to say, I don't understand why it works, but it works. And I was like, oh wow, I wish I didn't know you didn't understand why it works. Someone with a math degree should see it crystal clear in their head. So, by the way, in case y'all haven't noticed at this point, rarely are there 15 problems of new material. This assignment, most assignments have 15 problems. I think there's only 12 new material. Once you hit number 13,
it'll be something old, some old material.
Yeah, just reviewing. Look at this.
They can tell you that.
Y'all could tell me the answer there. Square root of negative 144? 12i. Okay, so starting with number 13 in this assignment, you check. It's just review. And we'll do that review, throughout the semester. But I think problem number 5 is the best one to do to start off or to show the process. So let's write it down. Tim, you going to do that? So solve the inequality. You'll notice it doesn't say anything about cut point.
It said x plus 4 is less than or equal to 2.
A little sequence of steps that you can find in the file on Canvas. And this way you can be looking at the steps as you go through them. Did everyone get a list of the steps?
No, let's see here.
Okay, I've got it. It's over here. Everyone.
Has anyone ever told you that the word
Oh,
I was actually going to say something related to fashion of as a joke or Halloween or day, 4th of the day after Halloween. We used to dress up quote unquote as each other.
We do that and people never think it's funny because we're so similar, how can they tell? But we do that especially when we don't want to dress up.
Yeah, one wears glasses without the lenses, and the other.
But the person wearing glasses it's funny because he's the one with the real good vision. The top part of these things is glass. I do not have a restriction for driving. I had cataracts removed in 2018.
Wow, Tim, your health.
I know. I was in perfect health until that cataract surgery where they put in the toric implants to correct my astigmatism. And
It's been downhill ever
yeah,
since.
and
but
these are just little reading glasses. The doctor told me don't wear regular glasses, just buy reading glasses. I kept losing those things every time I needed to read small print. Where are my reading glasses? So finally I went and said, okay, I want a pair of glasses that's just reading glasses, but in truth, because the top up here is just clear glass.
But
perfect
enough about your
vision.
perfect vision.
Oh, you're right.
Let's start number 5. And the natural question is, how do you know you're going to follow these cut point steps? But if there's a less than or a greater than, or a less than or equal to or greater than or equal to. Going back to that student that years ago told me his teacher was so stupid because he told him to study the instructions. And I just said, oh, wait, no, that's a good idea.
So we have an inequality symbol. That's what tells you you're going to have to use cut points. The first thing you'll do to solve an inequality using cut points is to ask yourself, okay, when does the left side equal the right side? Look at the instructions. Okay, here's step 1. You have the microphone. Why?
Let's read step 1. Replace the inequality with an equal sign and solve for x. And we'll call these numbers solution cut points for no reason other than I like to give them names. If you want to just say the cut points from step 1, okay. And we're going to eventually label those numbers on a number line. Remember, we're going to get something like this with open and closed circles. And I'll tell you here with the note how to decide between an open and closed circle. But let's first of all do step 1. We're finding what's called the solution cut points. I think I've already... So let's rewrite it. X over x plus 4 equals 2. I'm rewriting the inequality as an equation. Now that we know how to solve. In fact, I'm going to write it like this. Got 2 over 1. 2 words starting with a C and an M. What am I going to do on this in order to solve for x? Cross multiply. We would have 2x plus 8 equals, is that just going to be a 1x or x, however you want to write it? Now we need to isolate the x now. See, you're breaking this up into little steps, which you know how to do. Well, yeah, I'm going to draw some arrows. Here's what I'm going to do. Are these arrows, does it make sense what I'm trying to say to do? I'm going to move this x over to the left by subtracting x, and I'm going to move the 8 over by subtracting 8. So we have 2x minus 1x. Is that just going to be 1x?
So x equals negative 8.
Negative 8?
Yep.
So that's the first number. We're going to draw a number line and label. Okay? But step 3 is where we actually draw the number line. But let's go ahead and decide right now, are we going to put an open or closed circle there? If the problem is a less than or a greater than, use closed. If it has, less than equal to, greater than or equal to, use closed. If it's just a less than or a greater, use open. What am I trying to say we're going to do at negative 8? Closed. You look up here. So closed circle. I'll make a note of that. Or closed dot. I need to speak softer. Yesterday we were yelling because the microphone wasn't working. So I'll be quieter now. That's step 1. Now.
Oh, I like to number the steps. There's step 1. Yeah, there's step 1. And step 2 is usually a very short step. And so in the interest of conserving paper, I just put a little vertical bar and put step 2. What do you think of that, Tony?
Okay. On step 2, you only do step 2 if there's a denominator in the problem. A lot of these problems, there won't be any denominator, so you skip step 2. But for the first example, you see, I wanted you to see one where every step was done. Step 2, set any denominator that you have not equal to 0 and solve for x. Do you remember a few class meetings back? We said we can't have 0 in the bottom of a fraction. Well, that's what we're doing here. Where is this fraction undefined? And these numbers we're going to call denominator, or some people might call them domain cut points. I'll call them denominator cut points, and abbreviate those DCP. So Tim writes a 2, I'll write DCP. Where's my black? Oh, there's my black pen. No, this isn't black. The denominator of a fraction can't be 4. Can't be 0. So x can't be what?
0.
What? Negative 4. Now, can y'all read that recipe and tell me, am I going to put an open or a closed circle here? I'll help you. Always label denominator cut points with what? Open circle. So for the denominator cut point, always open. For the denominator cut point, it's always an open circle. For the solution cut point, you're looking up here at that symbol. If there's an equal sign on it, closed circle. If there isn't, open.
Now, let's think about why we would do that. Negative 8, if we plug negative 8 into the original problem, we'd get 2 is less than or equal to 2. As long as there's equality, the solution cut point satisfies the inequality. That's why we put a closed circle or shade it in when there's equality. If there were no equality, 2 is not less than 2, so you can't shade it in. But denominator cut points, you never want a fraction to have a denominator of 0, so you can't shade in that DCP. You have to label it with an open circle.
Because in shading them in, say you're including that as an answer. Open circles say you're not including it as an answer. You would never want to plug negative 4 in here. Because if you punch it into your calculator, negative 4 over 0 is going to say error, undefined, division by 0. Step 3, draw a number line and label the cut points. So I'll say step 3, I'm labeling it just like you do.
And here's my advice to you. Only label the cut points on the number line. Don't start numbering 0, 1, 2, 3, 4 like that. Only label the cut points. And remember, the small one goes to the left to the bigger one. So with that in mind, we have 2 cut points, negative 8 and negative 4. Which one's going to go first?
Yes.
Negative 8.
Okay, now this is going to be a little tricky. I'm writing the 8 in red, negative 8, and it's a closed circle. Then I'll put the negative 4 next with an open circle. And do y'all remember how we said you could label the arrows as infinity symbols? I'm going to go ahead and put a negative infinity and a positive infinity there. I'm wondering, can y'all tell the difference between my 8 and my infinity symbols?
One is sideways.
Yeah.
Now, so it's starting to look like what we have over here. The number line drawn, and we have some numbers with open and closed circles. Let's try to figure out which regions to shade. That's what step 4 tells you. Select a number in each interval and substitute it into the original inequality. When you plug it in there, if you get a true statement, shade the interval. If you get a false statement, we cross them out. So our graphs will actually look like this. Big X's. Okay? Through the intervals. So let's look at the number line. Test.
This is step 4. Put it on
Oh, step 4. Give me a number, any number you want, between negative infinity and negative 8. Negative 9, that's a good one. Now, what about a number between negative 8 and negative 4? Negative 5. Okay. And then a number between negative 4 and infinity. I'm going to choose that one.
You know something? I agree. Let Tony choose that, okay?
When I get to choose, I'm going to say 0. Is 0 between negative 4 and infinity?
Yeah.
Usually if you can use 0, that's the easiest number to use. But you could have used negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6, any number you want. Now, we'll plug these numbers into the original inequality. If we get a true statement, shade it. If we get a false statement, cross it out. So plug in a negative 9 in. I'm going to put a negative 9 here and here. And we have our calculator. We might need it to help us out. If I put a negative 9 in for x, we'd have negative 9 over negative 9 plus 4. What's going to be down here? Is that a
Negative 5.
negative 5? Is less than or equal to 2? It's sure not equal. But what's negative 9 divided by negative 5? Let's write that as a decimal, Tim. Punching that into your calculator. Is that a positive 1.8? Or you could write it as 1 4/5.
Either way.
We
Is
have,
that less than 2? Say yes. Yes, it
this is a true statement, right? 1.8 is less than 2. It would say true, which means shade that interval. Okay. And I'm going to mention something. If you know what the word alternate means, and you have a true-false test, and you know that the answer is alternate, if the first one is true, what do you think the next one would be? False. 90-something% of the time, more than that, these things will alternate. If I were going to just guess, I would say false here. And what would I say for the third one over here? True. And I'm going to go through and do it. And then I'm going to tell you how you can look at it and decide, does it alternate?
Just looking at this stuff right here, I know beyond a shadow of a doubt it's either going to be true, false, true, or false, false, true. You're not
False,
gonna,
true, false.
I mean, false, true, false. You're not going to have 2 consecutive true intervals. You won't have 2 consecutive false intervals. We'll tell you how we know that in a moment.
Mm-hmm.
Now
Okay,
go
so
ahead and verify.
let's
Plug
plug
in
in
-5.
a negative 5. I'm putting a negative 5 up on top, so we have negative 5 over negative 5 plus 4. Is that a negative 1? I guessed it was false. Did I guess right? Negative 5 divided by negative 1 is 5.
Yeah, you think that's correct.
Is that a true statement or a false statement? 5 is less than or equal to 2. Yeah, false. It's sure not equal to and it's not less than. And one more, though I'm pretty sure it's going to give us a true. Let's plug a 0 in. We would have 0 on top. 0 plus 4 is 4.
And that would just be 0 is less than or equal to 2.
Yeah, 0 is less than or equal to 2, which is true. This is the only time that I'm going to test every interval. My usual pattern is I'll ask, okay, where is 0? As long as 0 is not a cut point, it's usually the easiest to plug in. But you can really use any number as long as it's not a cut point. You can't plug in cut points. So let's go ahead and write out the answer in interval notation. We now have our number line drawn. Express the shaded intervals using interval notation. Square brackets for closed circles, parentheses for open. Always use parentheses at infinity symbols. Do y'all remember how to write that interval notation? So step 5, call it out. What am I going to write? Let me move this up. Looking at the number line.
Call it out the way you would if you were typing it in, because you're going to have to type it into my math line.
What will I write first? I'll get you started. Parentheses or bracket?
Parentheses. Negative infinity. Comma negative 8.
Comma negative 8.
Bracket.
Close bracket. Then you type a little U symbol.
It'll be in the toolbar.
Which means that it's still all in the same number line. It's read union or. Then what? Open or closed? Open. Negative 4.
Comma infinity close parentheses.
There. Y'all remember? Yeah. Y'all remember punching or practicing with this stuff on was it Thursday? Yeah, the end of class on Thursday.
So we come over here, and now we're going to punch in our answer, or type in our answer. What do I mean punch it in? We go left parenthesis, negative, and notice there's not a negative infinity symbol, okay? There's only an infinity symbol. So that negative you get from the keyboard. So negative infinity, comma, negative 8, and then a bracket. The bracket is taken from the keyboard, and right there, union. Oh, notice if you hover over that U symbol here on the toolbar, it says union, but right beside it is said intersection. That's the numbers that the two intervals would have in common. Well, there are no numbers common to both of those. You're going to be using the union, not the intersection. So it looks like a U. Then left parentheses, negative 4, comma, infinity, right parentheses.
I hate to say this, but are there any questions? What is this cut point method doing? Well, if you want to figure out when a number is less than 2, the first thing we're going to do, you find out where it equals 2. Then it's possible the fraction is undefined, and here it is undefined at negative 4. Everywhere else, it's either bigger than 2 or smaller than 2. So you find where it equals, you find where it's undefined, then everywhere else it's bigger or smaller.
And it can't change from smaller than 2 to bigger than 2 without passing through either equaling 2 or not being a number. Where is it equal? Where is it undefined? Anywhere else it has to be less than or greater than.
If you're there thinking, oh, Mr. Precella, these steps are hard, I'll tell you the secret method that our teacher used the first time we ever saw it. The method that we used was think about it. That's what the teacher told us to do. Think about it. Years later, it dawned on me, she didn't know how to do these problems. The first time I ever saw these steps, I thought, oh my gosh, why the heck didn't Doctor, I won't say your name, show us this rather than think about it? Okay? We thought about it until we came up with these answers. I suspect everyone missed those problems on the test, if you must know the truth, back when I was a student. And you had the same teacher, Tim. So.
No, I want to go back. When I looked at this stuff right here, this portion of the problem, I said I knew it was either going to be true, false, alternating like that, or it was going to be false, true, false, true. How did I know just by looking at what we had here that it was going to have to alternate? There are no even exponents. If even exponents pop up along the way, or even multiplicities, say you have an exponent of 2, then there's a good chance that there is a chance that it may not alternate. But it's more than that. I think I'm going to take the time. I have a little quick example, and we'll do it real fast. X squared minus 8x is less than negative 16. So, following our sequence of steps, replace the inequality with an equal to. So, here's step number 1. X squared minus 8x is equal to negative 16. And then we can add the 16 to both sides.
Because this is a quadratic equation, so either factor it or use the quadratic formula.
I'm going to factor this. So we have x and x. We know something nice about the signs. What are they?
Do you remember how to factor this?
No.
They'll both be minuses because there's a plus sign.
Okay, if the last sign's a plus, you have 2 of those first signs, so I agree with the minuses. And now multiplying to get 16, there's 1 times 16, 2 times 8, and 4 times 4. This is, okay, it's a simple trinomial. You choose the pair that adds up to give you 8, so 4 and 4. I think we're only going to get one solution cut point, aren't we? Because we have the same factor right there. That's x minus 4 equals 0, so our only solution cut point is 4. Okay.
Looking over here, is it an open or closed circle? Okay. It's not an equal, it's an open circle.
Make a note.
What uses more ink when you're writing it? The less than or equal, or just the plain less than? It seems like a stupid question, but which one uses more ink? Yeah, the one that has the equal to. Which one uses more ink, the open circle or the closed?
Drawing it in, you use more ink on that closed circle.
Student once told me that's how she remembered. If there's an equal sign on it, you've got to use a closed circle. It uses more ink than just strict less than.
I'd never heard that.
Yeah, I had a student tell me that several years back.
Okay, second step. Set any denominators. No, oh, wait a minute. I'm not through with this part 1. I wanted to draw your attention to something. Well, I'm going to wait on that. Let's just go on with the rest of the problem.